We get asked all the time what nanotechnology is. I'm approached with that question regularly. What is it? How does it apply to the vitamin world? Why did you decide to use it? Nanotechnology is the idea of using a very small structure to accomplish a goal. So you have a millimeter, and then a thousandth of that is a micron, and then a thousandth of that is a nano particle, a nano size. The smaller a particle is, it changes its physics. It can be used for different things. And even though that technology has been around for a very, very long time, it's never been used in this industry. What we decided to do is say, okay, how can a small particle help? And that's how it started. Doctors in the vitamin world have known for a long time that it's hard to get certain vitamins in the body effectively. You will find all over the country doctors who offer vitamin infusions, vitamin injections. You see it all the time. Why do those exist? If you can go buy vitamins at the grocery store, why do you need to go to a doctor to get an infusion or injection? Well, it's because doctors know it gets in the body easier. Because more of it gets in the body that he wants to be in the body versus taking something orally and have it not get into the bloodstream where it's supposed to be, and you just kind of pee it out the next morning. So we found that by reducing the particle size, introducing it sublingually, we can get very close to an injection or get those levels up way more than anything else on the market that's taken orally. And that's kind of the comparison I make when people look at the quality of an oral vitamin or supplement versus an injection or an infusion. We've tried to bridge the gap there, and using nanotechnology is how we did it. A lot of the doctors who have become customers of ours know that injections, infusions work better. They buy our product to stock in their office because they know that they can provide this to a patient who goes home and takes it daily. Not many of their patients want to come in and do an IV infusion for an hour that's very expensive and takes time, either monthly or weekly or daily. And nobody wants to do an injection every day. Nobody wants to take a B12 injection every day. How does our product bridge the gap between those two things? You can take a small amount every day and get your blood levels up, or you can take a injection once a month and have your blood levels spike and then taper off very rapidly throughout the month. The idea is that you're keeping a healthy level daily versus an injection that does spike. It does get the same amount in, but it's metabolized so quickly, it's really not effective through the month. It really, depending on which product it is, it becomes it's not very effective after a very short period of time. For example, glutathione. Your body will eat up all of the glutathione you introduce through an infusion within 24 hours. So if you do that once a month, you're really getting a boost for one day, but that's it. If you use our glutathione, you're getting a small amount daily, but you're getting it every day, and that's the difference. A lot of customers have asked us why we don't take our nano-sized product and make a capsule or pill out of it. We could nano-size the powder, turn it into a functioning capsule, or even press it, I guess, into a tablet. The problem with that is once it enters the GI tract and is exposed to the stomach acid and that harsh environment, a lot of it never makes it to the bloodstream. Turmeric is a great example. They know turmeric works in the human body. It works very, very effectively. But I think less than 2%, right about 1% of the turmeric you take orally that you swallow through a capsule or a tablet actually makes it to the bloodstream. Every product is a little bit different in why that happens. Some just can't hold up to the environment, the acids and the exposure to oxygen, water, air. I mean, everything that happens in the body. Other products are fragile. So what starts out as a chemical gets broken down. It's not that chemical anymore. Glutathione is a good example. It's very, very fragile and breaks down very fast. So how do you resolve that? How do you get to the point where you want to take something that we believe didn't work effectively, and make it effective? Well, you make it a transmucosal liquid that's absorbed immediately and gets into the bloodstream intact. One of the challenges with that is large molecules don't get through the mucosa very easily. So we nano-sized it, and that's how we got there. So it was a dual approach. It was, how do we solve the problem of the GI tract disintegration and breakdown of most vitamins, and at the same time get enough through the mucosa to make it effective. So putting it in an oil base with a nano-sized particle in it solved all those problems. We have doctors ask us, how our stuff is different from other oral liquids, oral drops, whatever you want to call them. We've never done studies head to head with other products, but there are certain characteristics we understand about all of these supplements and what they're put in. For example, glutathione is very, very unstable in water. We could put it in water, we could put it in a drop, and we could sell it to people, but it wouldn't work because it's unstable. The shelf life is very, very short. If someone else is selling a product like that, do we know it works? Do we know it doesn't work? No, but do we know the mechanics and the stability studies of those products? Yes. I can say with a high degree of confidence that if somebody is selling a sublingual and the properties of that don't match the chemistry of the ingredients, then it's probably not going to work. And again, without doing a head-to-head study with somebody else's product, I can't say for sure, but that's why we do studies. We do studies on all of our products. And we want to prove that they're stable and they get into the bloodstream and that what we're selling we know is getting where it's supposed to be. We could probably add a bunch of things in there that would make people happy. But why would we possibly corrupt a good formula with things that aren't truly helpful? Every time you add an ingredient to a formula, you have to look at how it interacts. We could throw, lots of things in there that make it taste a little bit better. But what if that causes the product to not be effective? What if it reduces the stability? What if it does something unintended that causes it to work less effectively? And we don't want to do that. We want people to get the most effective product with the fewest ingredients possible. That's what our approach is. As we add more products to our lineup, we want to make sure people understand that it's not a simple matter of using our technology on a product, throwing it in a bottle, and just providing it for public consumption. The technology we use is very particular, and when you get chemicals into the nano range, they start to act really funny. We, for example, tried to make CoQ10, and it looked like an orange version of cottage cheese. It was not an attractive end result. It wasn't stable, it clotted up, it was a very unpleasant visually end result. And we run into this quite a bit. For example, we get questions about vitamin C. When are we going to offer vitamin C? One of the reasons we haven't done that is because vitamin C is very easily absorbed into the body. I hate to say this, but there's almost no reason for us to make it in a nano-sized version. Does that mean we'll never offer it? No, it just means that it's not a high priority. Now, why is that? Well, because there's a lot of products that are difficult to get into the body, and people choose to take through injection or choose to take through infusion, or we know that it's so difficult to get into the body that they could be taken. Again, turmeric is a good example. You could be taking it by the spoonful and still not get enough into the body to achieve the results that you want. Mainly we choose products based on our ability to improve their effectiveness. That's our end goal. Our end goal is to make products that are going to be more effective than what's out there. After we choose a product, it takes quite a long time to get it to the public. A lot of people don't realize that even if we want to make something, it's not necessarily going to happen. The product may not be stable in the environment we have. It may not hold up under the pressure of the nanosizing technology we use. There's a host of reasons why a product may not make it, but the ones that do, we take through several steps. It takes quite a while. Making sure they go into the liquid base well, making sure they're stable. So you have to do a stability study. Then you process it, and you look at that end result and you go, okay, that looks good, it looks stable, it looks effective. It's attractive in appearance because we use droppers, and if it coagulates or has an unusual texture, lumpy, whatever, then you can't use it because it'd be give out teaspoons with our product would be kind of awkward. Once we have a product that looks good and we think is going to be effective, we do permeation studies where we take a membrane, we apply it to the membrane and measures what comes out on the other side. Once that's done, and if it works, then it goes to human trials. We want to actually put it on the skin, see if it gets into the bloodstream in the way we expect, and those measured results give us our conclusion. Is that going to go to the public or not? So after all those steps, people think, well, that's quick. Well, it's not. It can take months and months and months. And It's a long process. There's been a lot of products we've tried that haven't worked, and we decided a long time ago that all we would offer to the public are those products that we can improve and that pass each one of those steps. The reason we use Nano or Nothing as a slogan is because we truly believe that using our nanotechnology along with all the other processes that we take to get to a finished product produces the best product on the market.